So we had this form up with all of these angles. We needed to figure out what was the angle measure of that big arc X.
210.
So we got 210. So Amanda, how did you do that once again? So we just took 30 plus 90 plus 45 plus 15 plus 30, add it all together, and that's that total arc. So anytime you're looking for the angle measure of multiple angles, just add those degrees together, and that will give that total degree. So X of all of these added together. Be okay with that? So this week, we're going to start talking about angles and parallel lines. So today we're going to talk about angle pair. So we're going to look at what happens when you have two angles that are side by side that form a special pair. And we'll talk about four specific ones. There's three really, and then there's like a fourth that's half, not really, but we'll talk about it. So we'll talk about four angle pairs today. And then tomorrow we'll talk about parallel lines, and we'll talk about some angles that form parallel lines. Some of this stuff you may have been introduced in 7th grade. So some of it might be familiar to you, some of it might be new, but it doesn't matter if you remember or not. That's what we're talking about now. And so some of it you might catch on quickly, some of it might be fresh, but we'll see what you remember. All right, so we have three main types of angle pairs, and we'll add a fourth one on at the end of today that will sort of be added into this. So we have three main ones that we're going to start with. And so these are complementary, supplementary, and adjacent. So complementary angles are when you have two angles that are right next to each other. So we have angle 1 and 2, and they form 90 degrees. So when added together, these two angles form 90 degrees. So whatever the angle measure of 1 plus whatever the angle measure of 2 equals 90 degrees. And these should always be denoted with a right angle, or if you're told it's complementary angles, you should know it will make a right angle. So whatever the degrees of angle 1 plus the degrees of angle 2 equals 90. That's our first one, complementary. Our second one is supplementary, and it's similar to that. What do you think supplementary does? It's 180. So it makes a linear line, a straight line, or a straight angle. So this will be angle 3 plus angle 4, whatever those are, adds up to equal 180 degrees. Same thing like complementary, just it's a full arc now. This can also be called a linear pair because it makes a line. So those are the two words that mean the same thing. So complementary means 90, supplementary means 180, but it can also be called a linear. Just because those angles were denoted by numbers 3 and 4. It doesn't represent their angle degrees. So I can call this A and B. I could say the angle measure of A plus the angle measure of B equal 180. It's just how I denote English equals which. Last thing are adjacent angles. Now adjacent angles aren't anything necessarily special. It's just two angles that are next to each other. So they share a vertex, they share a side. So these two angles are considered adjacent. Technically all of these angles on the board are adjacent, because 1 and 2 are adjacent because they share a vertex and a side. 3 and 4 are adjacent because they share a vertex and a side. It's just another word. Complementary and supplementary angles are more of like a higher level of angle because they have something special about them. Adjacent angles are just two angles that are next to each other that don't have anything special. So if we wanted to figure out what this full degrees was, all you have to do is take 70 plus 55, and that would give you 125 degrees. But there's nothing necessarily special about them besides that. Are we okay with these three pairs? Once again, we'll add a fourth one in towards the end of the lesson, but we'll work with these three to start off with. So complementary, supplementary, and adjacent. These are words that are going to show up all throughout geometry from now on. And so whenever I say complementary, supplementary, we want to be able to recognize what those words mean. Keep that academic vocabulary in the back of your mind. Or when we get towards the end of the year, when we're talking about circles, circles deal a lot with angles. And you see like these two angles make a supplementary pair. We'll need to know what those words mean. So these are words we'll keep using that we'll keep having recycling through that we want to just sort of remember and always have ready to be able to recall. But sometimes we're throwing problems with these. So say we're supposed to find angle MG or MGH. The measure of angle GHL. Sorry, I can't read today. So GHL, if we remember from that first lesson we took, we remember how to right angles and name them, that middle letter is always going to be a vertex. So GHL is this angle right here with x degrees, and then we have LHK, which has 30 degrees. So if we need to figure out how much x was, what would we do?
Subtract 9.
So we know it's a complementary angle because it makes a right angle. So we can do 90 degrees minus our LHK of 30 degrees, and that leaves us with 60 degrees left over. Simple enough? Same thing with our linear pair here. If we were to solve for y, we know our right side is 115. This side is y degrees. All we need to do is take 180 because it's a supplementary pair, minus 115, and we're left with 65 degrees for y. Simple enough. Last one, we have the measure of ABC. No, ABC is 117. So this whole thing is 117. We need to find CBD, and we're told ABD is 40. So just like the other two, except we're not told, or except we're actually told what the angle measure is, we just take 117, subtract what we know to get the angle we want, and we're left with 77 degrees.
So this is actually very, does it get more?
We're going to relate it back to some algebra.
Then
So sometimes, rather than given degrees, we're given algebraic expressions. So we need to find the angle measure of each of these, but rather than being told of degrees, we're told this is 8x minus 14 degrees, and this is 2x plus 4 degrees. So we don't know what those are, they're just expressions. We don't know what x equals. How can we solve this? How can we figure out what the angle measures of each of these are? Gage? So, like this equals 180?
and then solve it with we don't have.
Close. I think I see this mistake often last year, is thinking that just one of these equals 180. But added together, they equal 180. So what we're actually going to do.
This is the last call for any staff or students who did not get their picture taken. Thank you.
So what we're actually going to do is we're going to take 180 equals both of these, 8x minus 14 plus 2x plus 4. So we need to make sure both of those added together equal 1, rather than just setting one expression equal. Do I need these parentheses even though they're here?
No, because
No,
I'm just going to combine them terms.
Yeah, we're just going to combine the terms. These parentheses didn't really denote anything besides that it's the whole degree measures, everything in there. So we can just drop off the parentheses. They won't be necessary. All right, so Morgan, you said combine like terms. So what like terms do I have?
8x and 2x and negative 14.
So 8x plus 2x gives us 10x. So those were both. And then our 14, or negative 14 and 4, they don't have x's, so they're like terms. And that gives us negative 10. Okay. So now we combine we're able to group together all of like terms. What are we going to do next?
Now do we just solve it?
How so?
Add.
So I have that constant. So that constant is the number that doesn't have the x next to it. The coefficient is the number that does have the x. So I need to inverse my constant first. So I need to do the opposite operation. So I'll add 10 to both sides. That cancels out. 180 plus 10 gives us 190, which equals 10x. Last step.
Divide by 10.
So inverse the coefficient. Right now it's being multiplied, so we'll divide. And then 190 divided by 10 gives us 19. So x equals 19. Are we done?
No.
So we were told to find the measure of each of these angles. So we know x equals 19, but we still don't know what the measure of each of those angles is. So we can plug it in. So what we can do is we can take 2 times 19 plus 4. What's 2 times 19?
36. 8.
Plus 4 equals 42 degrees. So I got 1. Now I could plug 19 into my second x to solve for my second one. That's one way to solve. Is there another way we could solve this?
180 minus 42.
We can just do 180 minus 42, which gives us 138. And that might be an easier way rather than having to plug 8 times 19 minus 14 and do all that math. You can just do this quickly. But those are both your angle measures. Any questions on this problem or how we set it up? So the main thing to look for is think, okay, what type of angle pair do I have here? So we knew they were supplementary. So we knew added together, they equaled 180. So you just take both those angles, set it up, equal to 180, combine all those like terms, start solving, get your x, plug it back in. Take a moment, see if you can think through and try this one. So you have your angle pair, you have 7x plus 30, and you have 2x minus 3. You want to solve for both those angles. So you saw these were complementary angles. You set them up as 90 equals 7x plus 30 plus 2x minus 3. Added together, they equal 90. Combine your like terms, inverse your constants, inverse your coefficients. We should end up with x equals 7 as your solution. Then we take that x, plug it back in to solve for what these angle measures are going to be. So you can do 2 times 7 minus 3. This is 14 minus 3, which equals 11 as one solution, or 1 degree. You can think what's 90 minus 11 for solving for the second one without having to plug it in, and that gives you 79 as your other angle measure. Are we okay with both of these? Cool. So the main thing for this is just being able to recognize what type of angle pair you're using. In this case, we're using complementary. The last one we were using supplementary, just knowing what they add up together to equal, setting those expressions in there as your angle measures, adding them together, and you'll be fine. All right, so we said we had 3 angle measures. We're going to talk about a 4th. So before we just jump into it, we're going to actually sort of think this one up on our own. So I have these 2 lines that are crisscrossed right here. They're intersecting. That math would like to throw in. So I have angle AZB, I'll highlight it, and then angles CZB. We want to think up or make a hypothesis on what we think the relationship between both of these angle measures are. Do you think they add together to equal something? Do they subtract to equal something? Can you multiply them? What are some thoughts on this angle measure? What was that? They're the same, or they have the same vertex. Okay. What do we think about the angle measures of them? Okay. You think they're the same? So AZB equals angle AZB equals angle CZB. I'm going to throw in a little thing extra. I'm going to put this little squiggly line up here. So with the squiggly line above equals, that means congruent. So once again, that word that we used in the past, congruent in geometry, it means the same. So AZB is the same as CZB. They're congruent angles. They have the same angle measure. Okay, so this is our hypothesis. This is what we're thinking. Let's try to prove this. So we don't have any information besides that, just what we thought and just this information. So we know we're trying to prove AZB is congruent to angle CZD. In order to prove this, though, we're proving it for any situation where you have lines intersect like this, any situation where we're dealing with these 2 angles. So we can't necessarily justify it to single degrees. We can't just throw in, I'm assuming this one's going to be 30 degrees. We can't solve like that. We have to solve without knowing anything. So I'm going to, in order to help us sort of keep these angles straight, I'm going to label that. I'm going to label this one as, this is x degrees. This one's going to be y degrees. I'll say this one's a degrees, and this one will be degrees. So those are just the degree measures of how much those angles are. They don't necessarily represent any numbers yet, though. We're trying to show that x equals a. That's our whole goal. So that's where we're ending up. We have to just figure out the path to get there. What are our thoughts? Dave?
Whatever.
We're gonna have to measure these.
So let's say we don't have a protractor. We can't measure that. We can't pull out our protractor and fit it on the board and be able to measure. So that falls. We can't do that.
Wait, should forgive me, cry.
Can't cry.
Wait, do we look like?
All of it is a full circle. 360, there's 4 things, 360 divided by 4, and there's 90, I don't know, probably, so then 1 is 90.
Okay,
Yeah,
But
you're right.
are they all the same?
No,
Or just these?
But there's,
About.
but the lines are 180, so you can.
So the lines are 180. So this whole angle measure, x plus y, is 180, right? So I know x degrees plus y degrees equals 180. Okay.
And can you do the other side too?
Like this other side? That makes a line, right? So a degrees plus y degrees equals 180. And I could keep going. I could combine a and b equaling 180. I could do b and x equals 180. So I have a lot of linear pairs here. Let's look at these two though. X plus y equals 180. A plus y equals 180. What do you notice about that?
They equal the same thing.
So no matter what number I throw in for y, in order for that to equal 180, x and a would have to be that same number. If I put 6 in for y, that means x would have to be 154. But if I put 6 in for y down here, that means a also has to be 154 in order to equal 180. So no matter what number I put in for y, it determines what x and a have to be, and that's always going to be the same thing. So did we prove that x and a are the same?
Yeah.
There you go. So that would be your proof for it. So we've now proven that these opposite angles, and even b and y, will always be the same thing. So x and a will always be the same, b and y will always be the same. So this works for any situation. Anytime you have intersections like these, those opposite angles will always be the same. Now we just need to put a name to it. We're going to call these vertical angles. So our vertical angles theorem that we just created, that we just proved, is that two angles that share the same vertex, that fall on opposite sides of the vertex, are congruent. So those will always be the same. And so anytime you see these, you can now always assume they will be equal to each other. It's pretty cool. You prove that all on your own. It's pretty impressive. So proofs is something in geometry that we'll keep using, that we'll keep adding on. When we get to triangles, a big thing is proving this triangle is congruent to this triangle. Or proving these triangles have some sort of congruence. Or proving that these angles are parallel. And so we'll talk about proofs more on in the future, but that was just sort of the first little intro. That's good. Very well. But now let's use these 90-degree angles, let's use these vertical angles. So let's say we're given one of the angle measures, 35 degrees. We need to find what all the others are. Where would you start? So I know x on this side is also going to be 35. Okay. What about y or z? Can I solve those?
Doesn't that take 70 away from 365 and split it in half?
Okay, so you're seeing the whole thing as 365 degrees. You're minusing 70 and then dividing it amongst these two because you know they're going to be the same. That's one way to do it. That's good. That's a sort of different way to think about it. Another way is thinking these two added together or these two added together is 180. You can do 180 minus 35, and that gives you, no, I'm sorry, I was doing 90 minus, that's not even right. I don't know what I was doing, never mind. So that should be 145, I'm sorry. So we know y equals 145, which will be the same for z, is also 145. And your method of doing it, Colton, would have worked completely the same. It's just a different way of thinking about it, just two different ways of solving the same problem. So good. So as soon as you learn one of those angle measures, you should be able to find all other three. And once again, this will probably be your most common angle pair that I think will show up in future classes or in future geometry lessons that we'll talk about. Will most likely be vertical angles, and then linear angles are also, or the supplementary pair is also a common one. Complementary isn't as common, but it will show up as well. So we want to keep these three straight and know which ones are which. Okay, let's try one other problem. So like your other ones, where you're given expressions rather than angle measures, except these ones are vertical angles. How do we set this up to solve? So in the other ones, we saw that they were supplementary. So we added them together to equal 180. What do we know about vertical angles? What was that? So all of them add to equal 360, all four of them. But we don't know these two, right? We don't have any information on those two. So we can't include those two in our situation. What do we know about these two then? They're the same. So I could write 3x plus 15. What does that equal to? 6x minus 75. Because I know they're equal to each other. I know they're the same. I can set those expressions equal to each other. And now we can solve. But which x do I start with? Which one do I solve for?
You have to get one, each one on another side.
I need to get them all on one side. So which side do you want to move them to? This side, right side, or left side?
That one's a good first.
You want to take the 3x over? Okay. So we'll subtract 3x. So these 3x's will cancel out. That leaves them with 15 equals 6x minus 3x, 3x minus 75. Why didn't I minus the 3x from the 75?
It's not like
Not like terms. I always want to make sure what are my x's, what are my constants, what are my like terms. So 6x minus 3x are like terms. So I was able to do that. All right, now I have 15 equals 3x minus 75. What do I do next? I need to get that constant over to my other side. I need to get rid of it. So I'm going to inverse it. So I'm going to add 75. 15 plus 75 gives me 30. Not 30, I'm sorry. 90. I'm all over the place today, guys. I'm sorry. 90 equals 3x. And now, in order to get rid of that constant or that coefficient, we can divide, and that will give us 30. So 30 equals x. So now we have our x. What do I do? Plug it in. So I can take my x, I can do 3 times 30 plus 15. 3 times 30 is 90, plus 15 equals 105. And if I know 1's 105, this one's also 105. If you really wanted to check your work, and you're afraid your x was wrong for whatever reason, plug it into both of them, and if they both come out to be the same number, then you're good. If for whatever reason you plug it into this one, and you plug 30 in and it doesn't equal 105, then you know you made a mistake somewhere along here. So that's an easy way to check your work. You're just taking that x and plugging it in for both. If it doesn't check out, then something's wrong. Are we okay with this? Yeah. So that's where we'll actually end it for